Welcome back. Today we will see about interference and system capacity. What is interference first of all? We all know very well interference is nothing but unwanted signal that affects the reception of the desired signal. It occurs when two or more radio signals use the same or nearby frequencies, which causes poor communication quality. A simple example let us see. Imagine that you are talking to your friend in a classroom. If only your friend is speaking, you can hear clearly. If many students speak loudly at the same time, it becomes difficult to hear your friend. This unwanted noise is similar to interference in wireless communication. Now let us see about the types of interference. One is co-channel interference. It occurs when two cells use the same frequency. It is caused by frequency reuse. Example, suppose cell A and cell D both use frequency F1. If these two cells are too close, then definitely their signals gets interfered. How to reduce this co-channel interference? Any idea? Just increase the distance between cells using the same frequency, okay, and also increase the frequency reuse factor and use directional antennas and also apply sectoring techniques. Next interference is about adjacent channel interference. It occurs when two nearby frequency channels interfere with each other. Usually it is caused by improper filtering or closely spaced channels. How we can reduce this adjacent channel interference? Use proper filters, maintain sufficient frequency spacing, assign channels carefully. Now let us see about system capacity. System capacity is the maximum number of users or calls that a cellular network can support at the same time while maintaining acceptable communication quality. Simple example, imagine a classroom with 60 chairs. If only 40 students are present, everyone gets a seat. If 70 students arrive, some students have no seats. Similarly, each communication channel is like a chair. Users occupy available channels. The total number of users the network can support is its system capacity. Now we will see some factors which are affecting the system capacity. The main factor, frequency reuse. More frequency reuse means definitely the same frequency can be used in different cells. Smaller reuse factor, the capacity will be higher. If the reuse factor is larger, then definitely the capacity will be lower. For example, if the frequency F1 is reused in many cells, more users can communicate simultaneously. If the cell size is small, then it can serve more users. Larger cell means only fewer users. Small cell means we know already more users. Example, a city with many microcells can support more users than one with a few large cells. Then, based upon the number of channels, if there are more available channels, then more users can be connected at the same time. Example, 100 channels, 100 simultaneous uses. Approximately we can say. Then interference. High interference normally reduces communication quality. We know very well about that. So if you need to maintain good quality, then the network may reduce the number of active users. So the system capacity will be lower. Then traffic load. During busy hours, many users try to access the network. If the traffic exceeds capacity, calls may be blocked and also data speed also decreases. If you see the relationship between interference and capacity, there is a trade-off between always there will be a trade-off between interference and system capacity. Increasing frequency reuse increases capacity, however, it also increases co-channel interference. Increasing the distance between reused frequencies reduces interference but also reduces capacity. So our goal of cellular network always to network design is to balance this capacity and interference. So if you so let us see some advantages of proper interference management. Better call quality, higher data rates, fewer dropped calls, and also better spectrum utilization, increased system capacity. So finally, you can define interference is the unwanted signal that degrades communication quality, while system capacity is the maximum number of users or calls. A cellular network can support simultaneously proper frequency planning and interference management improve both communication quality and network capacity. So now we know very well about interference and system capacity. Again, we will recall some points. Sources of interference include another mobile in the same cell and also the call in progress in a neighboring cell. Other base stations contain other base stations operating in the same frequency band. Any non-cellular system which leaks energy into the cellular frequency band. Interference is more severe in urban areas due to greater RF noise flow and also large number of base stations and mobiles. So there are two major types of interference we have already discussed. That is, one is co-channel and adjacent channel interference. Co-channel, you know, it is caused due to the signals that are adjacent in frequency. So the one main thing you should recall is co-channel reuse area. Q is equal to D by R root of 3n. This is the important formula, you have to keep it in your mind. And also co-channel reuse ratio Q is equal to D by R, where D is the distance nearest to the co-channel cells, R is the radius of the cell. It determines the spatial separation relative to the coverage distance of the cell.